actually you can turn down it a little bit. Yeah, smaller. Yeah, yeah, that's good. Okay, guys, this is Anima meeting. So if you are happy in the wrong room, you still have time to leave. So this is Anima working group. We have 2 sessions this week. This is the first session. We actually dedicate this session for the milestone work items. And we have another session on Friday, 11:50. That will be, has much wider topics. So this is a note wheel. Everybody should already know it. If you don't, please read through. You can either get it from any IETF website or working group slides. This is the working group meeting agenda. We are planning to go through the work item, 3 milestone work items today. Discovery and negotiation function, autonomical bootstrapping, and the autonomical control plan. Given the each topic has several talks, so we actually allocated different time slots for them. They are all agreed by speakers, so please keep your time. Oops, I jumped through one page. The blue sheet is already going around, so please make sure you assign it. And thanks for Laurent, volunteer for minutes taker. And actually, we still need 1 job subscriber. Anyone volunteer? Thanks, Mike. Okay, all the slides already uploaded on the material web page of IETF meeting. So if you can't see the screen, you can download from the website. Anyone has any batch for today's agenda? Goes once, goes twice, done. Okay, that's you can also see the agenda for Friday, reference model, which is also the milestone work items, but not in any urgent. So we save that for Friday. And the observations on bootstrapping and synchronizations, also coordination multiple autonomic functions and self-management network with fault management hierarchy, predictive risk aware for proactive management. So those speakers, I haven't get your slides yet. Hopefully you can send me the slides today, then we can upload it. And the audience has time to look at it before Friday. Thanks. The next will be Brian.
So under the new regime, I have to stand and think square.
Does that mic work? Can you guys hear at back?
Yeah, I don't. Is there a signal to use this next
I'm not sure.
In the other session, we had to switch off. There is no switch.
No, but there's no.
Testing?
Yes.
Yeah. Turn it off and on again, that would have worked.
Okay, good. So now this is where I have to stop doing email and stand in the pink square, because otherwise the remote people can't see me, and apparently they want to see me. And they can hear me. That's even better. And the great advantage of this system is that you can't actually see the slides, except by turning away from the camera. So next slide, please. So at the last IETF, we went through requirements for this, and we updated the document according to that discussion, but I don't want to go through requirements yet again. So I'm going to go into a brief overview of the protocol for people who didn't read the draft. How many people did read the draft, please? Okay, so some of you need the brief overview. And a quick protocol walkthrough, which is a little bit childish, because I had to take an example that could fit into a finite number of slides, but it's an attempt to show you roughly what we think the protocol will do. And then we have some open issues and discussion, except I think we're going to hold the discussion after the next presentation.
Yes, we are.
Yeah. So next slide, please. So the idea of GDNP is that it's a neutral platform. Generic is a very dangerous word, as has been pointed out to me, but we're trying to be generic and therefore neutral as far as the specific objectives are concerned. And what it is supposed to allow a node to do is to discover its peers and to synchronize certain parameters with them, or negotiate certain parameters with them. And synchronization and negotiation, in our minds, are two different things. And negotiation is an important part of an autonomic solution, because it's where two devices are agreeing what to do independently of any human intervention. The specific parameters and even the methods that correspond to those parameters have to be defined for individual use cases. They aren't part of the general protocol framework. And so far, we haven't actually defined one of those use cases in detail. So this presentation may leave you a bit hungry, because we haven't actually gone through that exercise yet. Next, please. So there's a concept we use called an objective, and it comes in three flavors: a discovery objective, a negotiation objective, or a synchronization objective. And that is basically a protocol element which defines a specific network parameter for a fairly general meaning of the word parameter. Right. Basically, it's something that can be described in technical terms. The basic protocol model is an initiator-responder model, where one party will start an interaction and the other party will respond. So it is intentionally not a multi-party protocol, which is something I think we'll find ourselves discussing after the second presentation. So discovery and negotiation and synchronization proceed by fairly simple, straightforward message exchanges. It operates above layer 3. We prefer IPv6, but actually there's nothing in the design that excludes operating over IPv4. And we think it's very important that everything is authenticated with replay protection, because if the control system of an autonomic network gets hacked, all hope is lost. So authentication and replay protection are very important. Next, please. Discovery, however, starts on link, because I don't think anyone's invented a way of starting a discovery process that isn't an on-link process. Maybe diverted off-link. This is a difference from some other types of discovery protocols. That if the resource you're trying to discover isn't on link, somebody will send you a pointer to an off-link resource. When you're in negotiation mode, it has to converge or fail in a few steps. We don't want very long negotiations. It's a closed loop negotiation between two parties, and there has to be a termination condition of some kind. Our view of synchronization is that it does not require iteration. It's an open loop operation. In some ways, I think that view is less strict than the DNCP view of synchronization. Protocol model is basically a type length value model. The value could be a single number. For that matter, it could be a single bit, I guess, or it could be quite a complex data structure, right up to a fairly complicated expression in a high-level format of your choice. Another thing which is an open issue at the moment is exactly what this runs over. Initially, we thought it would run over UDP, but there are reasons why that won't work in all cases. So then you might need to go to TCP, but if you want security, you might as well go to TLS. Or if you insist on security with UDP, you might go to DTLS. These questions are a little bit open. I have an opinion of where we should end up, but I don't want to force that opinion right now. Yeah. Next slide is correct. So here's the walkthrough. And I can't really point without going outside the pink square, so I apologize to the people who aren't in the room. This is a very elementary network with 3 segments, two routers. At the top, there's a certification authority and a registrar. And we're assuming at the starting point of this walkthrough that the 2 routers have enrolled, they've registered, they're known to the CA, and they have also acquired a prefix, which I'm going to assume for the purpose of argument is a ULA prefix. And they've got addresses, obviously, from that prefix. And the reason for saying ULA is this could be, at this moment in time, this could be a completely standalone network which hasn't yet got an ISP. And down at the bottom, we've just unwrapped a new box from its cardboard box and plugged it in. It's come straight from the factory. It knows nothing, has no configuration. Next, please. So the first thing that the newbie is going to do, is this a question for clarification?
Yeah, so when you said it had Tanistrophenip in my bag, do you want to see my bag? No? Okay, now bring it in a second. So when you said it had no configuration, do you assume that it doesn't even have, for example, a manufacturer-provided certificate?
That may be. In fact, I was going to sort of say that in about 1 slide's time.
Okay, so no means almost nothing.
It may have an identity.
Okay.
Yeah. So the first thing it does, and this is going to be an insecure process because it's not yet known to the system, it's going to configure a linked local address. It's going to wait for an RA, and it's going to configure an address under the ULA prefix. Right. That's out of the box IPv6, what we used to call the dentist's office scenario. Next, please. The second thing it's going to do, and it's still not in a secure mode, is it's going to send a GDNP discovery message. And the parameter of that message is going to be an objective, which will actually be defined by a number, because it's a TLV protocol. But the meaning of that number is, please find me the trust relay. It's going to discover a thing called trust relay. And this only works if there is a trust relay on the link, obviously. That will normally be the router. And then it will go through an enrollment process via the relay. And I don't want to answer Hannes's question because that is actually the topic of at least 2, if not 3 presentations later, right? But the assumption, working assumption for this slide is it uses draft Pritikin, but it could use one of the alternative solutions. So yes, at that point, it's going to have to present an identity, and that identity is going to have to be enrolled by some suitable magic, so that it becomes trusted. And that problem is, is not a problem of the GDNP protocol, except we use GDNP discovery to find that trust relay.
And Hanensing, and I suspect that the trust relay concept is also something that will come up in the other document, or it's not part of what you are presenting.
It's not part of what we're presenting, and if it turned out there were alternative mechanisms available, more than one way of doing this, not just draft Pritikin, then I think the response to that discovery message would say, and here is the method that I can provide, because otherwise we're stuck. Okay, next, please.
On this slide,
Sorry,
Randy Turner. This slide says discover trust relay. Is that some kind of multicast thing? Or?
Yeah, I'm coming to that in the very next slide will make that a little bit clearer, I hope. Okay, so now the newbie is known to the CA, it's enrolled, it also has got the domain ID, so it knows what it needs to take part in secure transactions. So it sends out a discovery message, which is a multicast. That's why I put two little arrows on it, pointing both ways. Okay. And when it does that, the status of all the other boxes, router 1, router 2, and another box that I haven't yet talked about, is they're all sitting in the GDNP listen state, which means they're listening for GDNP messages on a port. So that multicast, of course, is going to reach router 1, among others. So next, please. Turns out that router 1 doesn't know anything about this objective called money that newbie is trying to discover. So its job is to relay that discovery message on its other interfaces. And newbie and router 1 go into a waiting state in GDNP because they're both waiting for a response. And the discover money message has been repeated on the other network. If anybody knows a way to avoid that, I don't know. Next, please. And turns out this other box that has appeared on the network is already set up as an autonomic agent for this resource called money, whatever it may be. So it sends a unicast response to router 1, who made the discovery message. Router 1 is getting a response, but newbie is still in the wait state. Next, please. Router 1 relays that response, but what he relays is the locator, the level 3 address, if you like, the layer 3 address of the money agent. And I didn't fit it into the slide, but router 1 also caches that response so that the next time someone asks, the process doesn't have to be repeated. Newbie has now receives that locator and can connect directly with the agent it wants. Next, please. So they negotiate with GDNP. So that's the discovery process. And the discovery process I mentioned initially for the trust relay is a degenerate form of that process because we don't have any security. We're definitely not going to get redirected off link because we're not trusted yet, and they won't redirect us off link until we're trusted. So the trust management process has to operate on a link local basis until you trust the guy. Next, please. This is the same walkthrough, but it's a different format of diagram because what I'm showing here is that newbie sends a negotiate message to the agent saying, I want $100. The agent sends back a negotiate message saying, well, $50 actually. Newbie says, okay, $75. And the other guy says, okay, accept, which means the newbie has now become a new money agent, with a resource of $75. And I think there is actually a missing response at the bottom to complete a full three-phase commit that I haven't Haven't really thought about that deeply enough yet, but I think that's actually a protocol error at the moment. There isn't a final acknowledge. Now, of course, money is just a toy example. The sort of resources we're really thinking about are things like a fresh, well, one of Sheng's examples is a fresh supply of IPv4 addresses. If you run out of IPv4 addresses to hand out to your old-fashioned customers who aren't yet capable of using IPv6. And pretty much any of the use cases we looked at in the BOF two meetings ago, we believe can be mapped into this sort of structure. But all the guts of how this negotiation proceeds has to be defined in the specification for the money objective, not in the main protocol itself. So next, please. That was the end of the walkthrough. There's about 40-odd pages in the document, so there's a lot of detail in there. We would, of course, appreciate any amount of feedback on those details. That isn't the main discussion point today. So we have some open issues which I'll list, and then we'll move on to the second presentation before we start a discussion. Should we run over UDP or TCP? My personal opinion is that we should run over UDP for the discovery, and we probably will end up switching to TCP for the actual negotiation or synchronization interchanges, because they could get big and they need to be secure. So the second question is whether we use DTLS or TLS or the built-in security mechanism, which is in the current draft, but which we are more inclined to remove, or possibly IPsec, not completely off the table. DTLS is not completely off the table because I think, but it seems a little bit immature to us. And we should not forget that discovery will to some extent be insecure, in particular discovery before you have gone through the security bootstrap process will be insecure, but there's not much to be done about that. We have to do some work on DOS protection because we haven't done anything about that yet. Next, please. There is a discussion we have to have with Stuart Cheshire, but we have used what you might call a binary approach to discovery. Clearly, for high-level services, we expect people to be using a high-level approach to service discovery. The question is where those two meet in the middle. My personal belief is for a lot of the low-level network resources that they think will be administered this way, they're not suitable for a name-based discovery mechanism, but that's an arguable point which Stuart wants to argue, but he couldn't be in this meeting. But he did send a spy. Anyway, we don't propose to discuss that right now because it's kind of secondary to setting the general direction, which is what we really need to determine first in the working group. We need to work on describing the requirements for the specification of an individual objective. So if I was trying to write an RFC defining this money example, I would need guidelines on what I should be putting in that RFC. We need to do some more protocol walkthroughs and document those in a stable way. I don't know if they would ever become an RFC, but they certainly would be very helpful in evaluating what we're doing to have a set of walkthroughs. And we need to cross-check against all the other Anima documents, obviously. And we need to write some code. There is some code, but it's way out of date. So we could take questions for clarification now, or
only clarification.
Yeah.
I guess if I understood correctly, this is Mehmet Toy from Comcast. GNTP is over layer 3.
Sorry, it's
GNDP, the protocol is over layer 3. You stated
Well,
in the
actually, it's not really layer 3. We think it'll be managing mainly layer 3 resources.
Why is that? Is that because of the group's charter, or there is something else?
Well, first of all, I don't think there's much to be gained by going into head-to-head competition with DNS service discovery, right, for things that DNS service discovery does better. And yes, we are chartered as for autonomic networking, and that tends to imply layer 3 stuff in the IETF. There's nothing in the structure of the design that prevents it being used for negotiating dollars. That's why I chose dollars as my example, right? So, you know, you could use it for all kinds of things.
I'm sorry? Well, it's clearly, I mean, in industry layer 2 is being used very heavily, layer 2 and even below. So not including that over here, I guess it will make this as a half job in my mind.
We assume there is a layer 3 infrastructure. That doesn't mean you couldn't use it to negotiate layer 2 resources, right? But we definitely assume there's a layer 3 infrastructure. Yeah, absolutely.
Yeah, Michael Abrahamson here. Just there was a big discussion in HomeNet where people don't like ISIS because it goes over layer 2 directly and it's not IP. So I think bringing that in here as well is.
Shall we discuss routing protocols? Okay, one more clarification.
René Struik. Can you just move to back to the previous slide? So you have some remarks about item number 2, about costly crypto and simpler to bite the bullet and just use TLS. Could you elaborate a little bit on that?
I am told, I don't write code anymore, I'm too old, but I'm told that the code size and the compute time for doing an asymmetric key calculation for every packet is too high, right? And actually, I think Marcus can answer that question better than I can because they took the same decision for DMCP.
Well, obviously, I'm aware of the TLS details, but what do you mean by TLS? Because it's a family of algorithms, right?
Oh, yeah, okay. I don't know. The other advantage of using TLS as our solution is we can actually say that's not our problem, right? You know, the security guys can tell us a good profile to use.
You can use the brilliant track record of TLS, right?
Yeah.
Okay.
Yeah, let's move on to the next presentation, then we have more time to ask questions for both of the presentations.
Okay, hello, I'm Markus Stenberg and I'm presenting the DNCP variant that is called ADNCP. Next slide, please. What is DNCP then? It's because that's not probably familiar to most of us. The basic idea for it is, starting from the bottom of the slide, that each node publishes a well-ordered set of TLSs, which is oddly enough what routing protocols that are of link state type do too. And the nodes themselves have an identifier that is unique in the network. And based on those, we can order the set of TLVs also by the node identifier. So we have well-defined order for all data in the network, essentially. And we calculate node-specific hash for each node, and then we combine those node hashes to the network hash. And ultimately, the question of is our database in sync is actually a question of is the network hash we compute the same as our neighbor has computed. Next slide, please. How we actually then synchronize this is fairly simple. The option 1A on the slide is the case where we have trickle-based delayed multicast sending that happens at an interval that varies according to trickle algorithm on links. And that basically results in a system where the trickle state is actually in a steady state sent very rarely by one node on the link. And if there is changes, then there will be more multicast on the link. And the 1B option is unicast communication between parties. In that case, we also use trickle by default. So we can actually also directly via unicast using, for example, global addresses work across links. And the options, then the steps 2 and 3 are actually when we identify based on trickle transmissions that the network state hash that we have and the other node have are actually different, then there is simple request response exchange that basically exchanges the node data that are different. And as a result, eventually both nodes will have the same network hash, and as a result, the shared whole database. But next slide, please. As you can see, this DNCP is derived from HNCP original version, which was very application specific. But it has been sort of generalized, but it still remains fairly simple in a way that it's, for example, just single area link state database with topology information. But that has, of course, some scalability issues. But the other notable features are the trickle-based sending, which is very thrifty in terms of how much data it actually uses when the system is in steady state, as well as the fact that it is based on Merkle trees, so it doesn't need to transmit very much data if there is not much changed data to be exchanged. And the DNCP itself leaves actually various things to the profiles that are actually implementable protocols that employ DNCP. So for example, DNCP doesn't say what transport it actually uses, and it doesn't say which sort of TLS, for example, you want to use. It just says that if you want security, you want to use some TLS variant like VTLS or TLS or SCTP TLS or whatever. So next slide, please. And of course, being a single area routing protocol, it has some scalability issues. So even more sadly, if you use UDP transportation, because there is no DNCP level fragmentation defined, if you don't define some sort of per protocol fragmentation scheme, the UDP size will set some fairly strict limits on how large data nodes can publish and how many nodes you can have in a network. But those are actually not critical, because for larger case, you can just use TCP or define your fragmentation scheme. Next slide, please. ADNCP, on the other hand, is the autonomic variant for DNCP, and that actually covers those scalability issues. It extends DNCP with actually areas that are auto-configured and beautiful and not so very scientifically proven to be correct, but let's keep that for the moment. And it's TLS only, so it doesn't have the size limits that are implied if you use actually UDP. And it uses PKI only for authentication, so it can actually work also with a pre-thin bootstrap graph. And as a result of what ADNCP provides, it can actually do these point-to-point exchanges that were described by Brian, and it can also do graph-based multi-party things that I think are hard to do given GDNP. But that said, even if this in theory can do lots of things, next slide please, Anima plus DNCP doesn't have to be actually ADNCP, and I'm not sure if it actually should be. This was mostly an exercise in writing a scalable variant of DNCP for academic interest more than anything else. And I think interesting applications of DNCP in Anima are actually, for example, the one on the picture right now, where you have actually just some core set of nodes that share state using DNCP, and then everything else is doing something point-to-point or whatever. Maybe it may be GDNP or something else. Next slide, please. Or second alternative is that when you are implementing some specific objective, if you have actually need to synchronize state of a graph of nodes, then use of DNCP just for that, and just per objective is also an option. So those two are sort of examples that I find probably more likely to be useful than the ADNCP in and of itself. But of course, I welcome input. Next slide. That's it. No questions. Brilliant.
Can I see a show of hand who has read the draft? 3, 4, 5, 6. Thank you.
Bing Liu, clarification question. In this slide, it reads like there are some extension for the DNCP to make DNCP itself more autonomic.
Well, it is not really autonomic as such, but you can basically because it defines areas which basically provide for more scalability, because then you don't need to have every node that cares about state information to have actually exactly the same database. And secondly, because it also defines that, okay, fine, you can use these point-to-point TLV ranges for defining arbitrary messages for autonomic use, but it doesn't actually go into detail what these point-to-point exchanges would be. But I mean, trivially, you could define negotiation TLV, and then magically, okay, it would look pretty much what we saw Brian describe just a moment ago, using the transport that is specified for DNCP. So it's not really the autonomic name in the ADNCP in and of itself is a sort of a joke. It should be more probably like A for area or something, because that's what most of the draft text actually describes, and not so much the autonomic aspects of it. But
so the main goal of the ADNCP is some extension for fulfill the requirement in Anima context.
Well, I mean, it describes it as a way that I would argue that given current ADMCP, you can implement more arbitrary autonomic objectives than you can using existing specified GDNP. But it doesn't say that I want ADMCP to be used for that. I'm just stating that based on the current specifications, it seems that way. So it's hard to say if it's really designed for autonomic use, because I consider that in and of itself to be a sort of marketing jargon that I'm not very impressed with. So.
Okay, thank you.
So Stephen, about I think in general, ADNCP doesn't really add any more autonomic features to DNCP than it already has from the start. So I guess that is
scalability is the only thing that it's really
scalability really. But in general, the scalability issues aside, you can probably do the same thing with plain DNCP that you could with ADNCP.
Yeah.
Actually, I had a question.
Yeah.
Because we are chartered to do protocol to support generic discovery and negotiation.
Why is it called generic? Because I mean everything here is autonomic. Shouldn't it be called autonomic discovery protocol or something? Because I'm serious. I mean, because saying it's generic, it's really misleading, because you are aiming it for some specific set of things in any case.
Exactly.
So that's why I stuck the autonomic there, because clearly that design is aimed here, even if it essentially is just area extension for DNCP. And similarly, you guys have request reply protocol in GDNP, and I'm not sure how autonomic that is, but it's clearly aimed for these working groups purposes.
Yeah, that's fine. But like, my question is whether you consider your protocol design is enough to support any kinds of autonomical, requirements for the autonomical nodes to communication to each other?
Well, I mean, it's really hard to say, because it's very under-specified question. I mean, it can trivially do some types of discovery, some types of negotiation, some types of synchronization, some types of intent distribution. But I mean, all is really hard to say. I mean, but as I said, I'm not trying even to sell this, as I said at some point. So I think the whole discussion matter is mostly academic from my point of view.
Yeah, this is Brian. I mean, one of the reasons that GDNP leaves a lot of things open is precisely because we don't know the complete scope of the kind of resources and the kind of objectives we would want to manage. I mean, you're right that generic is perhaps a big word, right? But
I'm personally worried about the discovery that is not local, because that sounds like it's flooding, and flooding, if you have a large network, is really bad.
There are some words in the spec about how to avoid this becoming a problem. But yes, I mean, I'm a victim 25 years ago of ARP storms, and everybody who's ever been a victim of an ARP storm on a large network is very conscious of this issue, right? But on the other hand, we have the problem that we've set ourselves of managing discovery on an arbitrarily large network, which is not the case in HomeNet. right? Where even if you do flood an entire home net, you know that it's surely, even if it's Bill Gates' home, it's still finite, right? So the problem space is a little different.
Sending the broadcasts to every node in that network also doesn't sound sensible. So from my point of view, it sounds like you require some sort of central registry there. And that's what was the point of the, for example, the 2 slides before this one. The one with you have some centralized set of nodes that actually know everything, and then everybody else's set of clients.
But of course, this is the so-called God box in HomeNet terminology. And the point is, and a deployment could have one of those, because it could make sure that there was, you know, we're talking in our charter, we're talking about professionally managed networks. So if there was a very large network, we could presumably arrange for, you know, a certain number of God boxes to be present in the network so that they would stop the flooding of discovery messages. Except, of course, for a non-existent resource, which is an interesting attack on such a system, because then you can flood the network forever looking for a non-existent resource.
I mean, from my point of view, the correct answer to discovery in general is that you want to direct it to somebody who has a bit more wide idea about what's going on, and that's, for example, how I would do it on top of DNCP. Have some state there that points that, for example, if you have a bunch of areas, you would point it somewhere in the right direction, and you would need to do maybe a couple of lookups, but not flood it anywhere.
And
so
you know,
I would like something similar in your design. I mean, I don't personally want to push this design, as I said from the outset.
Now, the other thing that comes to my mind is the only real way to settle the question that's open is to take one of our use cases and try to design it for both solutions and see what happens. I'm not volunteering to do that this afternoon, but you know,
Yeah, let's say, for example, the way I see it even before getting to the validation use case is just to the other components. Let's say, for example, bringing up the autonomic control plane, right? Or the registration. I think there are 2 example use cases there, even just between these components.
Well, I think
the first one is negotiation simply between 2 neighboring routers, right? How would these 2, that's the most simple case we have, right? So how would these 2
but I think
protocols
both of the protocols behave exactly the same, whether they send TLVs at each other until the negotiation stops. So it's underspecified for ADNCP, but it's not interesting from my point of view. The interesting things for me happen either when you have something that deals with a larger set of networks or discovering resources or whatever, state synchronization across multiple nodes, because those are the hard problems. Point-to-point request reply is not hard problem. It's, I mean, it has been solved by a number of protocols over the years without, I mean, you could use DHCP-v6 for that probably by abusing some TLVs.
I think from a working group share perspective, the interesting part is that it's a necessary problem that we need to solve to make progress. Now, if it's a simple thing for the protocol, it still, you know, has to be, you know, a potential argument to choose one over the other protocol. If it doesn't help, fine. If both of them are good for it.
Running to be chosen as the protocol. The point is that this is an academic exercise that I don't mind if people take ideas from while producing a solution for the working group, but I'm not technically interested in actually pushing ADNCP to be a working group item in and of itself. So that at least puts my point of view, probably, hopefully, very clearly.
So will you be interested, you know, if we design, you know, assign a design team together, you and Brian and also other, you know, contributors who may be interested to work together with?
Possibly, although I like to be the outside commentator, as I said at some point. Okay. Although I got involved anyway, accidentally.
Okay. Matt?
Michael Richardson. I haven't read the DHCP document, but I have, of course, read the HomeNet originals. And so the 2 things that I observe, and I think we're supposed to have a combined discussion of both protocols now, right?
Yeah.
So I didn't understand oh God, I can't get letters today.
DNCP?
Yes, that one. Brian's document.
GDNP or GNDP?
Sorry. The first one, okay. I'm sorry. I reading it, I asked the, 6 or 8 weeks ago, I asked the question, well, what is this for? I don't understand. And I'm going to say that I still don't quite understand what it's for, because what I see is there's a resource owner discovery process, and then there's something that I observe is called DHCP v6, which is the allocation process. And I believe that there's really good, strong reasons to separate those two into different protocols for a whole variety of reasons. And I see ADHCP as being primarily, in this context, a discovery protocol that uses trickle.
Yeah.
And I believe, I'm sorry, that's not a question, but maybe it's confirmation. I believe that the property that if the nearest box can answer the question as to where to find this resource, that it will answer it, that it will happen. Oh, look, Max is a ghost in the thing. And that is the true both protocols, that they will go and answer from the lowest nearest thing, and so that caching function is really important. People talked about, to this DNS-like thing. Well, the DNS SD is not doing what we originally, conceived of, which was essentially some kind of a trickle multicast across the whole campus thing. So it's not doing that. That's not how they're solving their solution. And so that's pretty important to know that although it looks like the problem statement, it's not the same. Their solution isn't usable here. Okay, so let's not think about whether we could do this with DNS, because the answer is we probably can't and shouldn't. So my only question really is, I don't want to do the two steps together, and so I have a preference for something that looks like ADHCP if we actually need to do this resource location stuff essentially prior to bootstrapping. That's what I observed. This must be somehow important prior to bootstrapping. If you've bootstrapped, then it seems to me that you ought to be able to talk, well, not necessarily to a God box, but I think we have other protocols and other systems that would be able to do it.
Well, the thing is that you actually don't want to do this pre-bootstrap, because if you do anything that is non-local to the link, then you potentially open lots.
So if this is happening after bootstrapping,
exactly. I mean, that's what Brian's description told, and that's what I would have said if I had a complete presentation, but it was just...
But that's really interesting for me to understand, because, and so I'm glad I asked the question, because I thought this was somehow being done as a way to locate resources necessary for bootstrapping. And if that's not the case, then
what would you
then I actually maybe withdraw all of my comments, because I have to maybe think about it all again, because if it's happening after bootstrapping, then I think that there are some additional trust relationships that bootstrapping will have created, which may be far simpler to use. You may not have to discover stuff. You can be told them. Okay. Here's the Oracle, here's the whatever, here's the directed multicast you should use, here's the whatever, the Anycast address for the God box or whatever. So, thank you.
Yeah, the way to tell the new devices what the capability you already have in the network is actually another kind of discovery.
Yeah, and this is Brian. I mean, it could certainly be invoked at any time. It could be invoked when there's a partial outage. It can be invoked when there's another sudden heavy load that was not expected. So, some resource has not been assigned that would be needed to handle that heavy load. So it could be completely event driven. I was going to say something else, but I think jet lag has taken it away. But basically, that's why we did the UCAN BOF, and we had 7 or 8 use cases discussed there, and only one of them was bootstrapping, I think. Yeah, so it could be any time. But I also agree with Michael. If there is a pre-existing solution for what you need, we're not proposing that should be replaced right? You might, in such a case, just use the discovery mechanism in order to find the appropriate server. And once you found the appropriate server, you just use that server with whatever protocol it talks.
Michael Behringer. I really think we need to distinguish before establishing trust and after. We do need discovery before establishing trust, right? So there is a simple discovery mechanism needed to find the place that can help me enroll, bottom line. I really think we should keep that a separate discussion from what is being discussed here. And my recommendation would be for the discussion that you have, let's assume we have a common trust angle and we have a trust hierarchy. Then I think
yeah, I mean, the set of things you want to do pre-bootstrap is very limited, and you don't actually want to allow very many things to happen pre-bootstrap. So from my point of view, having that as a separate thing is sensible.
Absolutely. The only thing is we may still want the same base protocol, whichever we pick, to find a trust, a helper device, a proxy device or whatever. But then what we do after bootstrap is really a different issue.
Sure.
Hi, Tommy Pauly from Apple, and partially talking on behalf of Stuart.
We're cutting the line after you.
Okay, great.
So that nobody tries to get up again. Thank you.
Sounds good. So yeah, a question just more on this discovery process. Yeah, it's already been brought up that DNSSD may have parts that don't really match up with this, especially on the case in which you're discovering across multiple networks. You probably could look at proxying some of that and filtering it out, and I think that would be probably interesting to look at how you can use some of the existing, at least requests for discovery that you have from DNSSD and filter it out differently. But especially for that initial bootstrapping process, it seems like it's exactly a bonjour request for your, you know, I'm trying to find my trusted thing on my local network. It's a service. I need to get the address of it and talk to it.
Yeah, the point that I think some people don't quite get is that the assumption is that while GDNP has been bootstrapped, it doesn't mean that you have network actually functioning. The bootstrapping in this case means that you have your next hops have essentially are convinced that yes, you are a good guy. That's everything that bootstrapping means. You have gotten a certificate signed that basically proves you to your neighbors that yes, I'm part of the club. But the problem is that the club doesn't have, for example, anything else than IPv6 link local addresses at that point, and running DNS to in that case doesn't actually help very much from my point of view. I mean, I could be wrong.
So I mean, but it still was termed in phrases of you're sending out a multicast on your local link,
yeah,
looking for the specific service, and it seems.
Yeah, but the problem is that if it's not on the same link, then what? If it's on the next link and all we have is IPv6 link local addresses to deal with, because that's the question here that I would like to sort of solve in a way that if we have a network with 0 non-link local scoped addresses, how do I find a resource and talk with that resource is I think the point of this exercise, and most of the IP-based protocols don't assume that you have only point-to-point connectivity. So due to that, I think Michael Richardson's point of actually looking for a pre-existing work in this field might be optimistic, because I'm not sure if it exists.
Okay, sure. Maybe one comment here, right? One thing which I think Michael was referring to is there is a big difference between saying, can we do DNSSD over either of these protocols? And I think the answer is a lot easier than saying, oh, could we do MDNS over this, right? Because the solutions for MDNS, doing exactly the transaction that MDNS does, has led to a lot of complexity. We don't need to do this because we can assume that the endpoints that are talking the autonomic protocols would directly, you know, do any other form of DNSSD that we want to do that can be done simpler.
Right, and it may be good to look at just extracting just some part of it, not doing the full MDNS.
Okay, thanks much. So we're already talking about a lot regarding to bootstrap. Let's get on.
Yeah, and this is actually gonna hook up nicely with some of the discussion there. Also, the last part today, the autonomic control plane discussion, also hooks up there because it gives you an infrastructure in which you can run these particular services. But let's start here. So this is a way to bootstrap trust in a network, in an autonomic network. in a zero-touch way and yet secure. And we believe this is necessary in an autonomic network, zero-touch, because anything else doesn't really work in practice. And it has to be giving us a trust anchor off which to work. So the purpose of this draft is to automatically establish essentially a key infrastructure, call it the PKI hierarchy, for example, such that autonomic elements can talk directly to each other afterwards. Okay, next slide. So the draft has been around for a year and a half or so. From a fundamental point, nothing has changed. We have restructured it a little bit back and forth. So first, the bullets 2 to 5 describe an optimal approach, the most secure approach that we can come up with. The problem with the bootstrap draft, and also that's the same discussion we have with the netconf zero touch draft, is that there are so many variables in the whole flow that it becomes really hard to nail it down. And so we didn't quite know how to frame this initially, and so we started with, let's assume the most secure scenario, where then in HomeNet we were told pretty bluntly, go away, we never want to be that secure anyway. So we have then in section 6 things that you could do differently that makes the overall process easier but less secure. And explain, if you do not have an IDEF ID, you can use a serial number, and these are the consequences. If you do not have a master server, and so on and so on, right? So basically going through. And I think this is the only way to do it. Start optimum and then scale down. So here is the process in a nutshell on how we think this should work. There's a new device which has just been unboxed. This is Brian's slide showed it essentially this process in a different flavor. It talks to a proxy device, and the assumption that we make for the first version of, well, no, that there are several possibilities when a box comes up. Number one, it can find an autonomic proxy device. That's the slide showing here. Number two, it can not do that, and it can find a DHCP server, which gives it a DHCP address with a number of parameters, in which case that leads to a different way of bootstrapping over the internet, for example. There could be a case where the device has no information whatsoever and needs some local information to actually get started. So this one is the first case where we have a proxy device that we consider linked local. So this has to be a neighboring device that can help this device to bootstrap. On the gray device, we make no assumption. It has been unboxed. It knows nothing of the world. And then here's the process. So first of all, we run some form of negotiation, and that is exactly the discussion we had. And this is pre-trust establishment. But this is a relatively simple one, where essentially the two boxes exchange their identities, and the proxy device, well, it's a proxy as the name suggests, so it doesn't do much, but it forwards that to a central node that authenticates that device. And so again, here we have the 802.1 AR certificate, the IDEF ID certificate, which is the best security case because that we can really cryptographically validate this device. Other options follow in the next slide, right? So the registrar is a central point that will authenticate and authorize a device. Here now I need to know, I have two questions. Number one, who is that device? Authentication. And so the 802.1 AR is a way to authenticate the device. This is the device with serial number X, for example. And then it authorizes it to access the network. And for that, the most secure way is if you have a so-called master server service that validates whether a device, who has bought this device essentially. So it establishes a mapping between company X and the device it has purchased. So the registrar will essentially ask that service, here is a device with the following ID. I've validated the ID. It is that device, but is that my device? And the service comes back and says, yes, it is. And it passes on an authorization token That authorization token gets passed through to the new device. The authorization token is signed with the certificate of this vendor, such that the new device, which has the vendor CA information in there, can validate this is indeed from the vendor, and then can make its own decision whether to join the network or not. So we have authentication in the sense the network authenticates the new device, but also in the other way, such that the new device can only join the correct network. Now, this is the most secure way of doing it, and from there you have now millions of ways of scaling it down. And let me not go through that. One key point I want to emphasize here, all decisions are made in the domain. So the vendor never ever makes a decision. It can just say yes or no, but it is always a local decision what you do. You can always override that. Okay. Next slide, please. So one of the cool things about this approach is that a new device has only link local connectivity. That is cool for two reasons. Number one, if I have only link local, I cannot attack beyond the local link. I cannot attack anything in the network. What we do traditionally with DHCP, in my opinion, is somewhat naive. We first give a device an address that is routable, and then we say, actually, who are you? It should be the other way around. So this is the other way around. It has also the advantage in a bootstrap. The bootstrap that we have designed here does not actually require any config on the network. So you can bring up the entire network. I do not need an addressing plan because I only work on link local. And so DHCP is not required for this. It's a relatively elegant approach. You can authenticate the device. I already said that with the rest as well. So where should this be applicable? And we really believe that the approach should be applicable from top range service provider devices down to sensors. So on the sensor side, there's clearly more work to be done in terms of asymmetric crypto and the concerns raised earlier. But in principle, we want this approach to be the same everywhere. Next slide. So we've run this through 6TiSCH, and they have relatively stringent security requirements. Turns out that the security requirements that they have, for example, on the factory floor being separated from the security operations being separated from the internet, we can meet all these security requirements here. And those are the most stringent ones I've seen. So a new device on the factory floor must never ever talk to the internet, for example, and there's sort of this DMZ in between. Clarification question?
Yeah. Stephen Bart. One slide ago, you talked about that it's more secure than DHCP and so on. But if I add a device to a link which already has some sort of devices which are enrolled, and this device just happens to see an RA, then it can just guess the prefix, give itself a routable address, and then go routing and circumvent all your stuff.
No, actually, that's not possible.
Why? Can you please clarify that? Because that was my...
So the device does not get a routable address until it is completely enrolled, right?
Yeah, but for that you would need to have layer 2 security, right?
You secure the transaction after that. So even the first part of that should be secured with whatever protocol we pick, right? From
So you use that to assign addresses to a device?
Actually, in our approach, we don't even assign addresses. We calculate them. That may sound really wacky. Let me refer you to the last presentation of this session, which will go into more detail.
Okay.
I'm at with Comcast. Where is the authentication of the network? In other words, devices authenticating the network in your previous slide. Where does it show on this diagram?
So the new device gets this authorization token. If you follow the link that comes from the master server is the vendor service that says network X has purchased device Y. So it is a message which is signed by the master service, by the vendor, passed through transparently. You see it's unchanged over to the device. The device then sees my ID. I should join network Y. And then you can make a decision to join or not this network.
Yeah, but that's not authenticated. I mean, device is not authenticating the network. Network is the one who's providing that information to the device. Device is not authenticated.
The network is passing it through. It's not providing it. That's an important difference. The information is coming from the vendor in this case. The network is just passing it through, and that again I think is a feature because it allows the new device to be bootstrapped, for example, in a factory floor where you do not want internet connectivity, right? So it's a transparent pass-through, and it cannot be changed because it's signed.
Maybe I need to talk to you.
Okay, there are some gotchas, and also again, this is the most secure option. That has some drawbacks, so we have to look at all the options together. Next slide, please. So the same approach now is applicable also to HomeNet, and that is what I presented a couple of IETFs ago in the HomeNet working group. It is essentially the same flow. In HomeNet, we would leave away the master server. We don't need that at all. We probably cannot rely on IDEF ID in HomeNet, although I hope we can at some point, but probably we cannot. Then you would have some challenge response scheme, which follows exactly the same flow. But is less secure because you cannot, you don't have the hardware certificate, for example. I don't want to go through too much detail in the interest of time, but my point is we're trying to have a generic method that fits in many scenarios. That's really what we're after. Next slide. So discussion here, we rely on a link local proxy device. For the first of the options, if you actually read the draft, there are several options. So link local is the first. If I don't get a response there, then I will look DHCP DNS. And if I don't find anything, then I need some local help, basically. And so, for example, the netconf zero touch draft describes nicely the DHCP DNS option. That's where we have some common ground. We have consciously left out protocol discussions because first we want to settle on the overall flow, and it is actually envisageable that we have different protocol scenarios for different scenarios still adhering to the same flow. There are some things that we were asked to document. For example, if the master service, if the company that produced the device goes bust, what happens to that master server? Can I reuse that? We have a couple of ideas around that, but it's not documented yet, so that is in the to-do list. And also symmetric schemes, somebody commented on that.
Hey, Michael, I just noticed that Max is trying to say something too.
We'll see if this works.
Max?
Oh, excellent. Okay, to answer the question that was raised by Mehmet Toy, the authorization of the network is the join step on the by the device. What it does is it verifies the authorization token. The cloud service binds the registrar indiscriminately, any registrar, and to this authorization token. The device checks the authorization token, checks the binding to the network that it is actually communicating with. And if that is correct, if that's there, the device joins. What this is it's not a authentication of the network itself. What it is a verification that it has been logged and any other network can make the appropriate accept decisions in the future. And that's detailed in section 4.1.2 in the drafting. I'm open to further questions about it.
Thanks, Max. So again, what we are trying to do here is to come up with a common scheme for all zero-touch scenarios for different cases, and that is what we're really trying to achieve. And last slide, please, or second but last, actually. So there is the zero-touch bootstrap draft in netconf. And let me just explain briefly how this works. Also, that draft talks about IDEF ID. The left case is our case. There's a link local response. Then you use the method that I've just described. You receive a domain certificate. And with that domain certificate, you actually secure all subsequent options. So we are not talking directly about downloading configs or anything like that. We are talking about establishing a trust relationship. And that is important because autonomic interactions, as I said earlier, are not always going up to the central node, but they're also horizontal. Now, on the netconf zero touch, you go on the DHCP DNS case, so you don't have a local proxy. You therefore use DHCP. there is its own bootstrap mechanism, but essentially what it does, it goes straight into downloading something. That could be a config, that could be a script or whatever. And what is important to me, next slide, Jane, please, is actually that we should separate two things. And this is not how it's done in the IETF right now, but I think this is how the IETF should do it. We should first worry about bootstrapping security, i.e. the PKI hierarchy, and then worry what we do afterwards with it. Because once we have the certificate, then I can automatically secure, for example, the NetConf session or any other session that I may want to bring up. So this is a little bit of a philosophical question, but it's actually a quite nice storyline to have first security and then subsequent interactions. Welcome from Vancouver. And with that, I think I'm done.
Okay. Thank you. How many folks have read the draft? Just the 01, I mean. Yeah, everyone. Okay, cool.
Yeah, it's not many changes anyway.
Okay.
Okay, I think that was the last slide. Can you just check?
Yeah, that's the last time. Kent?
Any other questions?
First, no. First, do you what do you think about this? Is that, you know, because that's mentioned to your netconf 0 config draft. Do you think this is, you know, at least they describe something fact, describe something, you know, right for your draft?
Sorry.
I mean, this is what Michael describes the relationship with your netconf 0 config draft. Is that right in your point?
Actually, I think it was a pretty fair representation. Also, in my presentation, I'm going to try to make
okay, so
parallels to his draft.
So your presentation,
yeah.
Then. Okay.
The way that Michael described the netconf 0 touch draft seems accurate.
I think you need to enter the pink box now.
Mehmet Ersu, NetConf co-chair. I just would like to understand the dependency. I mean, what happens wrong if Zero Touch does not follow the proposal?
What happens if Zero
They're
Touch?
paralyzed, I think. What?
I don't hear you.
They're paralyzed.
I don't understand the question.
I mean,
just give you another automotive.
So what is the reason why should Zero Touch follow the proposal? I mean, would something go wrong if Zero Touch does not follow the proposal? So I just would like to understand the background and the dependency.
Let's maybe have Kent's presentation and then have that discussion, because I think it's
okay.
Okay, great. Hi, everybody. I'm Kent. I presented Zero Touch last time as well. So this is more of an update for your working group. Next slide, please. So in Honolulu, the fallout was that there were some issues with the netconf 0 touch draft, specifically that the owners of equipment had to interact with a third party in order to get their configuration signed. So there was a thought of a loss of privacy, you know, that they would have to share the configuration with the third party in order to get it signed. Also, the configuration was locked to an enumerated set of devices. There was this notion of a config lit, which is like it had an envelope and the payload was the configuration, but in the header was the enumerated list of devices. What this meant was that you couldn't just take the config lit and put it on any device, right? Loss of portability was the issue. And then lastly, and probably most importantly, it was unclear how it could be implemented. If we thought about, there's actually a request to the working group members to ask their constituent companies how implementable the solution would be. I took it to my company, and it also was found to be quite challenging. The notion of having like a real-time lookup service, or you know, how it would be easy to implement. And one of the other issues, the draft offered no support. There was no notion of how do you define what an owner is? How do you what's the identifier? So it offered no support. Next slide, please. So the current draft solves these solutions by replacing the third-party signing authority with the notion that rightful owners can sign their own configurations. I'll describe exactly how this is done in a second. And also that the devices themselves use a vendor-provided voucher to authenticate the rightful owners. So this fixes all the issues that we just talked about. Next slide, please. So it's a security-independent bootstrapping process. It's fundamentally a set of files, and it doesn't matter how the files are obtained. It's protocol independent. You could read it from a flash, USB flash drive, L2, L3, optical, IP, whatever. So this has a notion of flexibility to the solution as well. It's not a protocol. It's the zero-touch drafts protocol. I mean, it does define such a thing, but it's really just a mechanism for obtaining the files. And it's a convenient one that we feel like it's common enough that it's worth defining. So it's mostly an HTTP-based file server, a bunch of read-only GET requests to pull down the files, but there is one post resource where the device can be posting success failure notifications, which we find important. Actually, I think my co-author Joe Touch mentioned concerns for debuggability of the solution, and in discussions with others, it was deemed extremely helpful to have the Bootstrap server be able to provide reports as to which devices have tried to connect, did they succeed, did they fail, things like that. Lastly, again, it does have a protocol, but the use of TLS is just for privacy. It's not actually part of the security of the solution. Again, it's just a set of files. The files are signed. The fact that they're signed means they can't be corrupted in flight. So it's not actually, TLS is not actually being used to provide security. It's just, again, for privacy. If desired, the Bootstrap server could provide back a 402 WW authenticate header, forcing the device to authenticate itself. This kind of gets into the realm of, not autonomic networking, not zero touch, but something that comes up from time to time as we talk with folks is a desire for the, when they ship the devices to the customer, they want to ensure the right device got to the right customer. And so they would like the ability for the customer to enter activation code of sorts. And so they envision the device having a web portal with a form-based entry. They can type it in, and then that would turn into the device submitting its serial number, its username, and the activation code of the password. Next slide, please. Okay, just a little bit more detail on how this works. There's a one-time enrollment that occurs. So the rightful owner, when I say rightful owner, we could be talking about operators like Deutsche Telekom or AT&T or Verizon, or it could be franchise stores, retail outlet chains, 7-Eleven, Radio Shack, McDonald's. So these are large corporations and are trying to stand up these devices without doing truck rolls, right? That's a major use case for us. So that's the rightful owner. They would generate or create a private key and then do a certificate signing request to the vendor or delegate of the vendor. It would get signed and they get back what's called an owner certificate. It is an X509 certificate, and it has in it an owner ID that the vendor assigned, 1, 2, 3, 4 in this example. So then later, when they want to order some devices, they would place the order and supposedly they would check an extra flag saying, I want these devices with the additional zero-touch support files, please. And so when the devices actually do get shipped, they receive an email or some other out-of-band communication that includes the list of serial numbers and or just the ownership vouchers. Because each ownership voucher is in fact their owner ID and a list of device identifiers, which are the serial numbers or whatever. And then there could be an expiration date. So in some circumstances, the vendor may be able to vouch that you're the owner of the device for 3 months or a year, or if it turns out to be a specific SKU, no, you could be the owner of the device forever, right? So it's no expiration whatsoever in those circumstances. Okay, great. So now we have the certificate and a voucher. Next slide, please. So now the owner, the rightful owner, stages the network. They go to their network management system and they configure it. Here's the list of serial numbers that you should be expecting to call home into you sometime in the future. Or it could be providing that in the form of the vouchers. Again, the vouchers encode the serial numbers. They may encode go to the DSP server to provide a local list of URLs, additional Bootstrap servers that the devices could reach out to in a local network. So if you want to have a private network implementation, that's fine. But most importantly, they go to the Bootstrap server and they're staging those files. They're putting those files into the Bootstrap server. Again, the voucher and the certificate that they got back from the vendor or its delegate, the configuration, and here we, Michael was good enough to say that it doesn't actually have to be configuration of the solution. It could be anything. It could be domain certificate. It could be boot image, whatever. It's a chunk of data. So they have that data, and they also have a signature on the data signing with their private key. Next slide, please. All right, so here's the logic the device goes through. It's like the most important part. So it starts off, the course is in the factory default config. It goes to the DHCP server if the one is there, or maybe DNS or whatever, just to see if you can find some additional Bootstrap servers you might want to reach out to. It finally starts iterating over those Bootstrap servers, the ones that was manufactured with, plus the ones it discovered. And for each, it tries to grab its information. I don't believe I have the URL in this slide deck, but basically its serial number is encoded into the URL, so specific to it. So it grabs the files. Starting with the owner voucher, it says, was this voucher signed by my vendor? Yes, it was. Does it have my serial number? Yes, it does. So it extracts out the owner ID. Now going to the owner certificate, it says, was this certificate signed by my vendor? Yes, it was. Does it have a matching owner ID? Yes, it does. It extracts the public key. Now using the public key, it authenticates that the signature on the configuration matches. And if it does, it's cryptographically proven to itself that its owner, its rightful owner, as certified by its vendor, signed the data that's been asked to import. That's it. Next slide. So there's obviously overlap with the Bootstrap and key infrastructure draft. As Michael mentioned, both drafts have the device with a device ID. An IDEV ID. Both drafts involve the manufacturer delegating trust either to the customer, in my case, or MASA in the critical draft. Both drafts end with mutually authenticated trust. I actually didn't specify how the trust is mutually authenticated in mine. It's really one way in mine, but the data, if it is configuration, could include public keys that would then allow you to trust whoever you want to reach out to. So there are some differences in fuzzy lines between the two approaches as well, which I think is the more interesting part to talk about. There's a notion of the importance of the protocol. As I mentioned, the zero-touch draft is really a set of files. There's not necessarily a need for a protocol. There's no runtime exchange or interaction that's occurring with the network in order for the device to trust the data that it's importing.
I don't know if it's time to ask questions, but I can tell you how I would like to explain how we do things in ARM and whether that relates somehow to those type of things. So the device. So I sort of work it through with a public key-based version, but it could also be something as symmetric key. So during the manufacturing time, an IoT device gets a certificate, but it also gets information about what we call Bootstrap server, as well as the trust anchors for use with that server. Then the device gets shipped to the customer. When the device boots up, it talks to that Bootstrap server, and it obviously authenticates the Bootstrap server based on the trust anchors it has been provisioned with. It authenticates itself using the certificate it has gotten during the manufacturing process, a device certificate. It's not one of those IEEE 802.1AR or whatever it's called.
Sorry, is this a question?
No. Sorry, just continue. And then that Bootstrap server basically there's an enrollment step similar to what some of this PKI protocol does, ESD and CMP and etc. And it sends, so obviously there are different options, but I'll tell you one. This Bootstrap server generates a public-private key pair, signs the public key, and sends you basically so the certificate plus the private key to the IoT device. And it also sends configuration information that tells the IoT device with which server it can actually use that certificate, because in the background, not specified in a protocol, there's information passed around on maybe similar to what you said, like with serial numbers, but it could also be much more often that the process that is used is as an Excel file or something that can be used to import that into the respective server, provision it afterwards.
A question would be nice.
Yeah, so the question is whether that is somehow in any relationship to what you are doing, because I'm having difficulties seeing through the terminology. The Zero Touch protocol uses different terminology than the one document in this group, but both have different terminology to all the work that was done previously, and so I'm having a hard time to really understanding sort of the case whether this is actually solving the same problem or it's solving a
okay, so I think
different problem.
I think the question is a terminology issue, and that I landed on a word or a term that's overloaded, and I used in a different draft.
But it's
not
more,
related to that draft.
I think it's more than a terminology. It's just a question. Terminology hides or disallows me to understand whether you are actually solving the same problem that I'm dealing with, or maybe you're solving a different problem.
Yeah, you actually mentioned IoT stuff. Yeah, so we have next presentation, involves the IoT security.
Just one.
Can we discuss after the next presentation?
Just 10 seconds here, Michael Behringer. I think you're not solving the same problem because you started with we pre-configure the device in one way or another and then ship it. Both our approaches assume a complete zero touch, i.e. no pre-configuration. But I'd be interested in hearing your approach. Can you send us a link to the draft?
Yeah. It's actually a finalized specification by the Open Mobile Alliance that we are using. I sent you the link because it related to the question I asked earlier to Brian, what he actually means with having a blank device, and that's why he then responded to me, "No, there is something provisioned," and now you tell me, "No, there is actually not." And sort of like those are some of the things that I have difficulties reading between the lines of your document.
Max?
Oh, great. Thank you. So to get to the 3 points that you put on slide 9, I think that the Zero Touch draft definitely does incorporate those 3 steps. It's spelled out in section 4.1. I think we're very much in alignment there. The ownership voucher versus the MASA authorization token, the difference there seems to be that, and this is the question for you, I think from my reading of your document, you're expecting the vendor to be able to know from securing its sales channel exactly who owns which device during that claim process. And the real distinction is that in the MASA authorization token, it doesn't need to know that. Am I correct in that interpretation?
I think, well, first off, I actually haven't gotten to slide 9 yet, but to answer your question.
No, I'm sorry.
You're right. It's almost the same purpose, and to what extent the vendor is, it is the right. Who is the rightful owner? And what Michael just said actually is what I thought was interesting. He says the network knows that device Y belongs to this network, and I'm almost saying the same thing. I'm saying device Y belongs to this owner, but now there's a gray line of what does the owner mean? It could be the network, it could be an individual or an organization. So I think there's some interpretation. Yeah, TBD.
And I think the place where we'll need to get alignment then is that question of who the owner is or the network is. In the MASA concept, the MASA server never needs to know that. So there's no, we don't end up having the owner validation or ownership voucher service have to know who actually owns a particular device. And I think that's the only place where we need to go. So I'll step away and let you move on with the next slide. But But I think you're right that we can bring these things together pretty closely.
I think I want to get through the slides first, but I'd love to have the discussion about.
Can we close the line just for a moment? So let's get into
cases that are being addressed by the different approaches. I mean, clearly, what's my focus, my use cases are very different than autonomic networking and home networking. Okay, going back to this again, the importance of the protocol. There's not much need for a protocol here. Oh, sorry, previous slide. Yeah, the importance of the IDEV ID certificate. I did mention that both drafts have it, but in the zero-touch draft, it's not actually used for the purpose of importing that initial configuration. The device does not need to authenticate itself to the network at all. Again, it's just reading some files. It's only after it gets that initial configuration that then presumably configures it to call home or connect to its neighbors. At that point, it would then be using its IDEV ID certificate to authenticate itself to them. That's so it's a little bit when the IDEV ID certificate is being used is different. Validating data versus providing identity to the network. I just said that. Ownership voucher versus the manufacturer shared signing authority. Actually, same idea again. Image plus configure. Okay, so what is it that you're getting in the predicate draft? It's primarily the domain certificate, which is allowing for security. And Michael just pointed out correctly, I think, that bootstrapping security before taking to the next step might be a good thing. But definitely it is the case that the netconf zero-touch draft takes you directly into importing configuration, which can configure everything, the entire configuration of the device, including configuring to do netconf call home or restconf call home or whatever you want. And also there's a notion of image, so software images. You can pull down your software images from the Bootstrap server as well. The different use cases, my goal or focus is networking infrastructure like routers and gateway devices, where not set-top boxes. So there's very difference in that term. Also, SDN orchestration versus autonomic networking, right? So I'm very much of the opinion or the approach of having a central command and control or a God box, whereas this working group is trying to get rid of it. So there is that difference as well. Okay, I think that concludes the slide. Oh, sorry, slide 9. Meeting in the middle. So zero-touch draft definitely should incorporate the idea of going from linked local to DHCP. Currently only describes using DHCP, but the others are great. Bootstrapping draft might leverage the notion of ownership voucher. We just touched on that a second ago. It's TBD, kind of the interpretation of it both. And both drafts or another could define some overarching principles enabling multiple mechanisms. So I'm kind of the opinion that it's okay for a device to have more than one mechanism, so long as a denial of service attack on one mechanism won't lead to a less secure bootstrapping mechanism. Okay, so that completes the presentation.
Okay, thanks a lot.
We're running late, so next, let's finish the presentation.
Did we? I don't think we got a show of hand who had read the netconf draft. Can we just have that for a second? Okay.
We're running late, so be quick. I have to cut down a little bit of time. 8 minutes.
Behind the schedule, so I will make it fast. Well, this presentation is about the survey of security bootstrapping in IETF, actually, because I submitted draft for 6-law analysis of the IoT security bootstrapping, and I think it will be valuable if I put the discussion here. Next slide, please. And as you can see, what are proposed so far in IETF, there are at least 7 drafts, and some bootstrapping solutions are based on certificates, and those certificate-based authentication message can be carried by using EAP TLS or EAP IC version 2, and the others don't want to use certificate because of some considerations, because the communication cost is too high and the computation cost is too high. So in 6-law, they propose to use raw public or pre-shared key. And all those messages can be carried by using EAP. Next slide. And this slide compares the different credential materials. As we all know that certificates provide high security. It can also provide mutual authentication, but it use PKI infrastructure and decentralized architecture. The computation and communication the cost is very high, and besides, we should pay more attention to avoid trust complex trust dependency and secure dependency. The other is the self-signed certificate. It provides high security, but it doesn't provide any authentication function. And it's able to be realized in a decentralized way, but the computation and the communication cost is as high as the certificate.
Hannes, just a brief comment. I think all these three mechanisms, certificate, the raw public key, or the pre-shared secrets, allow provide authentication, but of course you have to, the type of validation you do is different for those cases. That makes it sometimes a little bit difficult to compare. On the level of security, it's hard to say on which one is better because it depends on many factors. So that's a tough aspect.
Yes, agree. So right now the raw public key also provide verification, but we need to do some modifications during the communication. And the other is pre-shared key. The security is fair, and it provides future authentication, and it can be realized in a decentralized way. The communication cost is very low, but it has the key management problem. And the other is proposed by Thread Group, and I assume they use a product install code. The security is high, and it's a one-way authentication. I'm not sure how they can realize the mutual authentication from the server side. And it should be realized in a centralized architecture. The computation and communication cost, I assume, is very low. Next slide. So my question is, can the previous two solutions can be used for other networks, such as SDN and IoT? Here, I just demonstrate the example of what's the difference between the traditional network and the IoT networks. The devices can use different communication technologies in IoT, and there are also different function capabilities on the devices, and most of them are constrained. And the things can cooperate with each other for routing and for other things like application layer service. And the network, there may coexist different topologies in the network, which means mesh, star, and tree topologies can coexist. So when we design the bootstrapping solution, we should consider the network topology into account. So the next slide. Okay, this is just example showing how the topology in IoT network is for those who are not familiar with these kind of things. So next slide. In my humble opinion, I think the design consideration for good security bootstrapping should follow several rules. Well, the first is to able to clearly define security dependency and trust domains. The second is that it should consider cross-layer protocols. No, it should consider other layer protocols to realize a cross-layer design. So, which means that maybe the scheduling at MAC layer should be considered during the security bootstrapping to avoid network congestion, and it should also take into account the routing protocol as well. Third is that it should reduce human interaction to the minimum. It doesn't mean that it should be completely automated, but it should be able to reduce human interaction to the minimum. And the next is to be able to resist attacks. I will analyze later this item. And the last one is that it should reduce to the computation cost and communication overhead to the minimum. Next. And this table compare in details of the two previous drafts. And we can see that they use different number of credential materials, and the zero touch use more than the Anima. And it also requires to install more information on the devices, if I understand correctly. And but Anima bootstrapping infrastructure use more devices to involve in the security bootstrapping procedure. But the common block is that the DHCP maybe are the same, and the bootstrap server may be the registrar in that paradigm. Okay, the vendor side, the vendor may be equivalent with the master service and the factory CA. And the Anima bootstrapping key infrastructure introduced domain concept where there's no domain concept in zero touch. And the zero touch introduced ownership concept where the Anima bootstrapping key infrastructure doesn't have an ownership concept. Next. So what's the problem of applying both methods for IoT network? The proxy or the router in the Anima solution right now can also be constrained things, which means that DOS attack may occur because they are used to forward the configuration information to the joining device. As a result, the energy will be consumed very fast if many devices try to access those services. And the second is that the ownership, in my opinion, is more important for IoT and should be considered. The third is that register certificates cannot be used to validate ownership. I don't know why registers certificate is that important to a joining device. And I think to validate the owner's manipulation is more important rather than to validate the register. And the other thing is that the DHCP service may also generate some attack issue, such as DOS attack. 2 minutes. Okay. Because and the cost of the DHCP service and constraint things should be estimated. And the reflect attack may occur in DHCP configuration. And the domain certificate will increase the burden of the constrained devices, and the relay of the certificate will, of course, generate more authentication message for constrained network.
We don't take questions. We are running late.
Okay, regarding the zero-touch solution, as we can see, there are many pre-configured credential materials stored on the device, which may be the drawback because many devices in the IoT are constrained devices. And the other things that just relationship of zero-touch is more complicated, and it should be succinct for IoT, I think. And the same DHCP service security issue also occur in this zero-touch solution. And the ownership is preferred for IoT, but in zero-touch solution, if I remember correctly, they just pre-installed in the device, which is too rigid. As the ownership may be changed, how can you handle this problem? And the relay of the certificates costs higher than the Anima bootstrapping key infrastructure. Next. Yes, this is last slide. I think there are several works to be improved for both works. And the most important thing is that do we need one framework that supports different credential material, as both drafts only support certificates? The other is that do you consider different topologies? And do you consider constrained devices? And how about the level of ownership? They may be different. That's my presentation.
Yeah, thank you very much, and sorry that we've run out of time. So I think we need to move on to the last presentation. Can I get a show of hand who has read this draft? Okay, 3, 4, thank you.
Sorry, you are also cut to 15 minutes.
So this is about the autonomic control plane. Bear with us. This is a wacky concept at first. If you look at it and you haven't seen it before, you think like, what the hell are they doing here? Excuse my language. Bear with us. There is some reasoning behind the whole thing. And I think we've come up with a way to bring up a network completely zero touch and completely automatically without any need of configuration. And that is useful. Next slide, please. So in the reference model, we see that there are autonomic service agents, which we are not defining in Anima at this point. We are defining the autonomic infrastructure, which is sort of underneath that layer. But autonomic service agents need to talk to each other. That's why we need discovery and all those mechanisms that Brian was talking about earlier, for example. So essentially, they form automatically that autonomic control plane. Now, next slide, please. We have several ways of doing this autonomic control plane. And so I just loosely define that here as all the transactions that happen between autonomic service agents. We have several options, and those are in the definitions draft. Out of band is sort of out of scope as well. Configured overlay is also not that interesting. The last two are interesting. We have in-band, and that is what we do today. Every interaction between two devices, every control plane that we have is today in the data plane. And that has a number of advantages, number of disadvantages, and the key disadvantage is you need a working data plane for your autonomic services to work. And a data plane involves planning, it involves addressing, it involves all sorts of things that today have to be set up manually. So what we've come up with is a self-managing overlay network. That is what we call here the autonomic control plane. This is self-managing. Imagine a VPN on top of the network following the logical topology, completely self-managing, independent of the config of the device, and independent of routing, independent of the data plane. So how do we do that? Next slide, please. Yeah, what we've done in the document here very quickly, yeah, details. You can read that afterwards, not important. Next slide. So here is how it works. One more, please. I think this is one more. Go through the animation. Hang on. Okay, thanks. So here's what we do. An autonomic node, and be that what it be in terms of function, can be a router, a switch, whatever, creates first a virtual context, like a virtual routing and forwarding instance, for example. Here is where we need those certificates now. Right? This is where it all comes together. This is why we first do the certificates. Now the devices can authenticate each other directly because they have a common trust anchor. And we run some negotiation to negotiate, for example, the tunnel type. Then they establish a tunnel, for example, TLS, DTLS, IPsec, whatever. You plug those into the VRFs and do that hop by hop. And the trick with the whole solution is that we base everything on IPv6 link local. That happens automatically. In fact, IPv6 link local is also an autonomic process in a way. It just happens, no config needed. So this entire infrastructure is following the physical topology. It goes hop by hop from autonomic device to autonomic device. It builds up this infrastructure. In there, it creates loopback addresses, and I have not included the details on how we do that. But basically, when you get a domain certificate, a device gets a name and a domain address. So node 17, and the domain is example.com. And we create a ULA address mechanically. We calculate a ULA address based on domain and the node name, where domain makes the prefix and the node name makes the last 80 bits in total. So this follows the ULA specifications, but what's nice about it is once you have a node name, you don't need to think about the address. Needless to say, this is not aggregatable per se, right? This comes up in a flat address hierarchy. But I have an address for every device, and I have a name for every device automatically. Well, the name has to come from the registrar. So now I build up this red infrastructure. I put the ULA address that I've calculated on the loopbacks, and I run a lightweight routing protocol through this red infrastructure. It's a VPN essentially. It's an overlay network. We use Ripple in our approach. We run this through here, so that devices can find each other, essentially. And now if you look at what we've just done, there is no dependency on the control plane. In fact, I don't need routing in the data plane here. Don't need it at all. I also do not need a configuration on this device. The configuration of the device can be empty because this is essentially an autonomic service that establishes this autonomic control plane. And the nice thing is here we are sort of in a management domain with its own address space, its own namespace. It automatically comes up. And it allows you now to manage the network through this channel. That's the whole idea behind it. And if that is not entirely clear after the first explanation, I'm afraid this is normal. It takes a couple of iterations till I find it hard to explain. Next slide, please. So this is actually the best example of an autonomic process because all of this just happens. There's nothing you need to do about it. If a device has enrolled, if it gets a certificate, and the neighboring device has a certificate with the same trust anchor, then the default behavior is, for now, we can change that later on, the default behavior is I will establish this autonomic control plane to my neighboring device without need of any conflict whatsoever. And that means I now have a management type network, VRF gray, you could say, but automatically established over the entire network. And so there are two use cases for that. Number one, if you want to bootstrap an entire network, today you have to bootstrap the first node, but then you need to upload a config because you need the data plane to get DHCP through and whatever. So you need a config, you need to configure DHCP, then you can bootstrap the next layer, and so on. You always need the config on the device to bootstrap the next device. Here you do not. Right? So you need to get the domain certificate down. It will automatically establish the autonomic control plane, but I don't need a config for it. It'll just work. And that has actually a second very nice use case. You can use it as sort of an out-of-band channel. Today you use out-of-band, for example, if you mess up your configuration and if you cut yourself off a specific device, for example, by misconfiguring AAA. And that happens fairly regularly to pretty much everybody. So either you have an out-of-band access to the device and can get to console and you can recover, or you send somebody in a car to locally fix that and plug his computer into the console port if you don't have that. With this, you can, not all, but a number of misconfigurations you can actually capture through the autonomic control plane. You have access through this red channel to the device, even though AAA may be messed up, routing may be messed up, whatever. So these are the two immediate use cases. And so what we see this as being useful is it is a channel that is self-managing, that is not dependent on the operator. This is where we think autonomic interactions, what Brian was discussing at the beginning, should go through in an established network. As I said, we need also some negotiation to bring this up in the first place, but the majority of autonomic service agents should go over this separate control plane. And one of the other advantages is it's more secure than if you're running the data plane because you can't get packets into the VRF. It's a VPN essentially. Next slide. So this is the end of it already, so lots of time to ask questions and interact here. We have four options. Really, we are talking about the first two here, in-band, and that will always clearly be a requirement in some scenarios to have the control plane as we have it today over the normal data plane. That is always going to be one option. But one important feature we see is this autonomic overlay, where we have added security because we are not in the data plane, we cannot be reached in the data plane, we are not dependent on config, and so on. Now, these two likely have to coexist in many scenarios, and so there's another draft from Turles that explains a little bit more about the coexistence and how these two things can be used in parallel. This is all a lot of stuff, and I hope it was clear, but I'm sure you're going to ask questions.
So I haven't read your draft, so forgive me. What are you configuring? If I got a router, I have line cards, I have all the routing database and everything else. What do you configure on this scheme, with this scheme?
We are not configured in that we are not configuring. Right?
Okay.
What the autonomic control plane is independent of the config, has nothing to do with it. So what if you use that mechanism today, and that is in shipping products, by the way, so there's an implementation of that. This will come up, and it's at your disposal to, for example, to log into devices through the autonomic control plane. But it is independent of your config. So what you do in your data plane, OSPF, ISIS, whatever you want to do, is still the way you do it today.
Nice.
So this is of the overall picture of autonomics, which is that big, we are covering that much. Right? Let's be clear. Right? This is a tiny, tiny, tiny space.
I'll take a risk. This is Brian. I'll take a risk and say, if you wanted to run netconf over it, you could.
Absolutely.
Yeah, because if you decided you were going to configure your routers using netconf, despite all our words about everything being self-configuring, this would be a safe tool for running netconf. That's just a random example.
Very fair point, Brian. And also, let's be clear. We are not talking in the IETF really about fully autonomic nodes that have no dependency on configuration. For the long foreseeable future, we actually think that a part of the device will be configured in a traditional way, and you will always have certain things that you want to configure manually, and there will be certain processes that will be autonomic, and those could use that autonomic control plane. Right? And so we believe this is a really useful concept for a number of reasons. We believe that should be the basis for autonomic interactions, and netconf is just one of the other interactions that you can run over it. It gives you a fairly solid basis for bringing up autonomic service agents in always the same context, the same address scheme, same name scheme. Security is settled. Basically, we are trying to establish a basis on which to build on.
So Michael Abrahamson. So one thing I'm liking here is that the device might need some kind of minimal config in actually to be able to get its connectivity up and running. It needs an SSID, it needs a DWDM frequency, something in order just to connect to the network. And this is not solved by this. This works if you have a cable that you plug in, and then you don't need anything else to start speaking there.
That is a fair point, but that belongs to the previous discussion of this one.
Yeah,
Here we
okay.
assume we have a certificate, but yes, your point is right. If I need some information to bring up even layer 1 or layer 2, I have a very fundamental problem that we may not be able to solve. And so there will always be, and I think we say it in draft predicate, there will always be the case where I can absolutely not have any reachability of that device, in which case I will need some local way to inject something. To get it started.
Yeah, Mohamed Boukader from Telecom. Forgive my fixation about this a service provider angle with this problem is that you know, when we are managing networks, there's one key term which is deterministic behaviors of our network. So to have a full control of the behavior of the network. So is there any way in the system that you are designing here so that you push a button in which I will call it an exit button so that you can, if for instance there is a fuzzy behavior of your autonomous network following the rules that you have described in your presentation, is then a fallback mode in which you will just behave following some legacy ways of operating the network?
Well, actually, the reason why this is being implemented in products is exactly because we do not interfere with the normal data plane. That's it. I mean, this is a drawback and a benefit at the same time. A drawback because it's, I mean, if you look at the big picture, it's not extremely powerful, but the benefit is if you configure your normal data plane and your normal telnet, SSH, whatever you want, that works ships in the night with this, right? So you keep in control of that.
Yeah, and just talking about the interface between, yes, these two should not be, that is something that should be included in the design itself, or should be left to the operations.
I don't understand the question.
You know, if you have an autonomic behavior, if you know that will find out, for instance, the way it will discover the neighbors, the way it will be assigned or compute an address as you mentioned, and etc. But for instance, if there is an attack based on exploiting some of the doors in the system, and then there will be the system will want to be stable.
So if you want that the system to be stable again, then to shut down the autonomic behavior of your node, come back to the legacy way. So that's my question. How is it something that should be part of the autonomic behavior design itself, or this is something that should be left to the way the network are operated? That's perhaps this is beyond your presentation, but
you can do this either way, right? Ideally, you want an autonomic function to monitor itself somehow, and maybe if it gets into a fuzzy state, that it backs off. But yeah, clearly that's beyond what we are discussing here at the moment. Something we have to discuss at some point. I agree. Any other question?
Thanks, Michael. Perfect timing. A quick question. Who already read this draft? Raise your hand. Okay. We'll ask other questions on mailing list, whether that's useful.
But fundamentally, can we? I have absolutely no feeling how you guys think about that. Is that useful? I mean, does that make sense to you, or are you okay? Like,
take that to mailing list. We are running out of time. So thank you, guys. See you.
A quick hum, though?
Sorry?
A quick hum we could have, right? It would be interesting.
Views?
For the autonomic control plane. No, I think we have this overlay autonomic control plane provides benefits. Do you guys agree with that, or do you think this is off the board? Okay, would this be useful? Do you see this useful in some use cases? That's the hum. How many of you say yes? How many of you think no?
Well, you can always find some.
Okay, thank you, guys. Hopefully see you on Friday. Thanks. Everybody sign the blue sheet. Okay. Not too bad.
Oh, that's you.
Well, let's see if we can catch up on Thursday or something like that. All right. By the way, do you know what our security